Alright, so jumping into the first problem, fin's effectiveness is the ratio of a heat transfer from a fin surface to the same surface that doesn't have a fin. So this value is going to be greater than 1, while the fin's efficiency will be less than 1, but still a positive number, because this efficiency represents the ratio of the actual heat transfer to the ideal heat transfer at the fin's base temperature. So then looking at the next conceptual, a fin should be attached to the outside so that the air is more effective to it because it has the lower heat coefficient. Jumping into the numerical problems, for this one it has water flowing through a pipe. So you're just going to use the Q pipe equation seen here with the efficiency, now accounting for that. And then using this equation to solve for the base temperature, you're just going to be using several area equations and length equations to get to the, I like to call it a squiggle. And then from this squiggle, you're going to solve to plug back into the unknown variables of this equation so that you can finally get T base, and then solve for the Q of that, using this equation. Next problem is looking at pipe again, and you're going to see the effects of a fin on it. So a long fin, an infinitely long fin, you're going to use this simple base equation, find that it's about 125 watts. Looking at it, if it's adiabatic, you see that the Q actually does decrease to 96 watts around. Looking at the Q at 250 degrees Celsius, using this equation, you see that it continues to decrease to around 90, 91. And then Q with convection, this long equation, you see that the Q actually goes back up a little bit to 98.5. And then use these equations to graph. And finally, looking at the last problem, for a conduction board. To start off, you're going to see that R total is R board plus R convection. Get the equations for R board and R convection to solve for it, get that answer, and then use the Q equations to see the difference between the R total and the R boards. Not that much, about 0.2 degrees Celsius. And B is looking at the same thing, but on a more complex scale with polymers and aluminum. So following these equations, you get to your base temperature, your new base temperature, and then using that new base temperature, you're going to solve for Q's again to see that the difference is still 0.2.